Welcome back everyone. In the previous lesson we looked at the different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In this section we're going to dive deeper into reinforcement learning. We previously discussed how reinforcement learning involves learning from experience and experimentation in terms of how you interact with an environment. And these interactions are a major source of knowledge about the environment and also ourselves. Continuing with our example of training a dog, we refer to the dog as the agent, the entity we are training. The agent makes decisions to perform certain actions in the world, known as the environment. Depending on whether these decisions and actions are good or bad, the agent is positively or negatively rewarded. Over time, the agent will learn, based on the outcome of its actions, being the reward, which actions are good actions and good behaviour is incentivized. To sum this up, we are aware of how the environment responds to our actions and we adapt our behaviour as a result of that feedback. This is not dissimilar to how humans interact with each other. Maybe you crack a bad joke and the response from your friends is not so positive. You'll learn and hopefully not repeat that same kind of joke again. Let's look at some ways you can apply reinforcement learning towards real-world problems. Playing games is a great example of applied reinforcement learning. Take the game Breakout. The objective of the game is to control the paddle and direct the ball to hit the bricks and make them disappear. A reinforcement learning model has no idea what is the purpose of the game, but by being rewarded for good behaviour, in this case hitting a brick with the ball, it learns that over time it should do that to maximise reward. Another example is controlling and coordinating traffic signals to minimise traffic congestion. How many times have you driven down a road filled with traffic lights and have to stop at every intersection because the traffic lights are not coordinated? Once again, the reinforcement learning model wants to maximise its total reward, which is done through ensuring that the traffic signals change to keep maximum possible traffic flow. A final example of reinforcement learning is for self-driving autonomous cars. It's preferable that cars stay on the road, don't run into anything or anyone, and travel at a reasonable speed to get their passengers to their destination. Our reinforcement learning model can be rewarded for doing these things, and will learn over time that to maximise reward, it should do these things. Thanks for watching, and see you in the next video.